Hello everyone. We will discuss about current scenario of sustainable design in today's lecture at international level. So if you see this slide over here, so this is actually biopolymer based composite material was used actually to fabricate this structure, and this is almost like a 5 meter tall. Okay, and this structure is actually fabricated out of like a cellulose, chitosan, and pectin, which are the actually naturally occurring like a compounds. Okay, so this structure is designed out of that. The biggest characteristic of actually this structure is that it responds to the surrounding. Okay, it has the capacity to breathe. It has the capacity to actually bloat. It has capacity to actually absorb water, you know and so this is actually quite compatible for the as a use as like organic matter in the building structures, though it is just actually an innovation actually from an architect and her team. But this is actually very praiseworthy actually, the effort in terms of using organic materials for fabricating actually structures out of them. So here if you see, this is the actually architect Neri Oxman. She has actually done this work at MIT Media Labs in MIT, United States. And with this one actually she has 3D printed and a whole structure out of it. So if you see the biologically inspired and engineered actually the design has come up from the inspiration of using like a natural materials. So this the wherever we are designing this man-made environments, so in such environments, these kind of materials can be utilized. So here if you see this biomolecular building components, they exhibit actually some tunable properties, so which we can actually tweak with, which we can play with, and the form, function, and fabrication of it, it involves like an innovative understanding of this material, innovative application of this material. So this is an actually wonderful exercise what we can see over here in this right bottom image. So this structure is being actually 3D printed over here, and it looks like a flexible skin. So if you see this has actually some inspiration taking from the leafy breathable structures, where the structure is supported from the beneath using the tubular actually structures which support the overall membrane part of it. Okay, so computationally if you see this is a modified with the mechanical, the chemical composition, and using optical properties of this material, this overall effect you are seeing over here. So it breathes like a natural like a skin. And the structure what it has is follows this like a human skin like, or like maybe a leaf like actually structure. It has actually some properties like translucency and viscoelasticity. Okay, it behaves in a certain amount of rigidity is also there, and certain amount of a flexibility is also there, and that happens actually because of the property of this chitosan and cellulose which is used in its fabrication. So if you see, the based on the explorations, and based on the density of the fibers, this has evolved into a structure of this scale. And it has actually, see in this right bottom actually figure, so you can see the structural and structural strength of this material, like how long it can sustain itself, okay, as a independent actually a structural member in any a bigger actually member. So as the skin responds to the humidity and heat, and so does actually this materials, because it has some properties of a breathability. Okay, in the next example I would like to showcase over here, this actually sculpture is made out of completely using scrap materials. So it actually promotes recycling. Okay, it promotes actually reusing the waste material, and this is actually created out of the scrap material completely. This is another project actually taken from a Netherlands. It's a museum project which sits near close to actually a water body, and rather the site itself is a kind of interacts a lot with the like a water body. So the water streams are actually flowing through this water body, and this is a renovation project which was undertaken by actually this a team over here from the Rotterdam, and they used this green roofing this strategy to minimize the actually heat load and integrate actually this design into the landscape. So they have actually used this as a, like a renovation, and they have integrated this into the beautiful surroundings of this place actually over here. This museum actually utilizes the water safety principle, and it actually helps conserving the water on the site also. So as you can see over there in this actually illustration, so this is the overall site which is inundated with water. In the most part of it is on the bottom side, and there is a like a water stream which flows from beneath the site from the building itself. And as a strategy, the architect has utilized actually this water stream to bring the temperatures down in the like summer months. And they have actually utilized like a material conservancy actually principles to reduce the amount of like waste generated from this energy, and reduce the energy consumption also. Okay, so with the blown up view, you can see over here like how it has actually organized its activities and functions in the building, which actually minimize the energy consumption as the overall term. So it takes the advantage, the biggest advantage of the like a site, because it's close to like a water body. So it utilizes that as the biggest actually feature of this design itself. As you can see over here, there are like a water based actually power generation units are also installed to generate actually power for this museum over here. It uses heat resistant glass. It uses like a green roof for like a added like a insulations, and like a heat buffer, okay, reducing the overall like energy requirements of the building. It uses actually this biomass based like stoves, so that maintain actually temperature, okay, on this in the like winter times. Okay, on the warm days actually water from the river flows through the same piping to cool the buildings. As I said earlier, the water from the site itself is utilized for bringing for controlling the temperature in the summer months. Okay, here willows are used also to absorb the wastewater and substances it contains, such as nitrogen and phosphate. These substances actually acts as like a nutrients to grow like on the site itself. Another example I have taken over here. This is actually energy park. This is a this has been actually being implemented in the city of the like a Masdar in United Arab Emirates. So this is designed by an architect and her team from like Chennai. Here like what they have done is the utilization of the like a solar energy to convert it into the power. So as these Gulf countries actually experience extreme heat, okay, and extreme like a glare, so that is actually is one of the like a fitting places to have like a more number of like a solar harvesting like units. So she has used it as like a deployable power system which harvests actually energy from the like a sun, thermal energy like a storage system also. It is works as like a for the power generation as well as storage system also on the site. So you can see this peculiar actually structure of this design. It is designed to like have a a concave surface with the like using like a hyperbola and parabolas, so that to maximize the actually heat gain out of this like a structure with the minimal like a use of this material. So it works like synergically to provide a clean and sustainable sources of energy, and it harnesses actually solar energy, and it harnesses actually wind energy also. So you can see in this uh, okay, in the next actually slide I'll show you, there is the third unit also which harvests actually wind power. So if you see like this region actually receives very high solar irradiance, so that is the purpose actually like and mostly like in the summer times the sunlight stays there for like a longer period of time per day. So how this can be made into a like a attractive solution, attractive like a destination for like an urban actually a feature, urban landscape like a unit. So that is very interesting to observe through this design. So the concentrated actually solar elements harvest sunlight to make thermal energy from a strategically designed curved mirror surface onto a focused collector. So the this collector you see which is passing from here. So this actually is heated by the glare which gets concentrated from this actually is the surface, the glass surface of this these dishes. So these are actually parabolic in shape, and they have actually higher conversion efficiency. And the mirror films are coated with the like a very high reflective like a coatings up to like a 95% of this they actually reflect. Okay, so here if you see this third unit, which is right here in the middle of it, this actually harvests the wind wind velocity and converts that into energy. So it has the composition of like a two solar panels plus one actually wind panel. So this uses actually lightweight durable ETFE membrane, okay, coated with like a mirror film, which is a very lightweight as well as very effective for like a such like a purposes. Okay, it uses like a fluidized sand. It uses like a steel as a like a membrane as a like a main structural system. It has like a wind turbine system. It has like a, it uses like a carbon fiber reinforced plastic, okay, CFRP also, and it's like a blades to make them like a lighter as well as very efficient and strong. And piezoelectric tiles are also used to generate energy while having like a people who will be the like visitors. So by the footfall of the visitors, that tile surface also generates some amount of energy. Okay, on the landscape it uses like obviously the native species sand and previous actually pervious paving, which collects like water, which allows water to seep inside the floor. In the next example, this is actually an academy building. Okay, this is from Vietnam. So you can see in this sketch over in the lower side, this also utilizes this terrace garden concept to minimize the overall like energy requirements for this building. It uses like a fins and membranes to permeate to allow actually permeation of a wind without actually harming too much with the like a direct sun. So there is this courtyard corridor planning arrangement all across this surface you can see over here, which allows the greater amount of wind, but it prevents the direct heating also of the interior spaces. Okay, so this is basically an educational facility. Okay, this is situated in a like outskirts of the like actually that town. So it is located in a like a rich green actually area, a foresty area, and it utilizes that climate also to for its like a greatest advantage. So it utilizes actually the wind pattern and the solar orientation. So here if you see the wild variety of like a lush green plants and vegetations and fruit trees are also like a kind of planted, and it houses around like 800 students for their education. And it has the like abilities, it has that potential that integrates with the landscape. So you see from here the students can actually climb on the top of this building, okay, gradually from the ground level itself. So you can see over here this green roofing concept in this illustration, and there are like interesting courtyards carved out surrounded from like a building from like a three sides. So here and here. Okay, some more details of it, like it uses like obviously like a passive design building like a strategy. It uses actually ordinary reinforced concrete frame structure with the brick and mortar as a like to have like a mass of the wall, okay, and which reduces actually the transmittance of the heat also in the daytime. On the external vertical luvers and pattern walls like this, they have used you can see over here in this particular image, it creates this shadowy pattern. So it allows the light permissible amount of light to get inside the actually corridors, inside the like workable areas, but it prevents the extra glare also, it prevents the heat component also. It allows that air buffer to get created over here. So these luvers actually help reducing the warming temperatures inside. Okay, so visual connection is also established here. You can see this the double height actually penetration is like left just open so that the students can see through, and the landscape can be visualized actually with the greatest like efficiency. Okay, this another example is taken from the country of like Nepal. This school is also present on the outskirts of the town, and it enjoys actually this hilly terrain, but the hilly terrain offers a challenge also, like where the children are going to play. So in that kind of like a setup, like the designers, the architect team has actually deployed has taken advantage of the roof of the structure of this building to create actually playing areas, and having like a bigger surfaces where students can actually safely play around, as well as at the same time they can enjoy the view of the like a valley and the mountains. So this actually promotes playfulness and stimulates actually learning in a natural like setting. It actually uses that stepped actually planning of that like a terraces, like a terrace farming we have seen from the like mountains. So it enjoys it utilizes actually that strategy to have like a stepped courtyard planning, to have it in this like a school building. And there are three actually major blocks you can see in this plan of the building, which allows actually this ventilation, cross ventilation from the middle of these blocks, which allows actually greater like a air movement in the like a warm months. Yeah, you can see some playful incidences over here, like how children are like enjoying actually this structure. And you see this architect Aman Raj, he has actually created a 1:10 actually a model of this portion of this building in the sand itself on the site. So you see like how he has taken advantage of these sliders, as well as steps on a like a with the greater like risers, to have them arranged in a like a seating fashion, like a ghat kind of like a place and an arrangement where children can like stay on these terraces and they can play. The next example I have taken is from like Auckland. Here the architects has visualized kind of a wrap around like these vertical trees. So without actually disturbing the site, without actually disturbing the landscape, without actually creating any like a man-made structure of like a concrete and brick in the like ground, they have utilized to stay like these utilize these tree trunks to stay afloat on the sides of these like a tree. So it's a bubble kind of like a structure you can see created in like a timber, which they have wrapped it around, and they have created actually interesting like a dining spaces inside actually these bubbles. So this has actually in the recent time has catched actually the fancy and the imagination of the public over in that country and even internationally. And it's an actually effort, we can see that effort like how to pay like attention, how to pay respect to the nature, how to pay respect to the vegetation and trees, and evolve our designs around them. So it's an actually, it may not actually last there forever, but at least it gives us a kind of an intention, like how we can without much harming the actually landscape and the setting, we can still evolve like a creative solutions, out of these like a varying actually context, okay, which are offered by the landscape and that particular place. So at a time this one structure actually offers like a support for like a 30 diners at a time, and it gives them like an ample like a ambience to look around this green wooded area. And all of the services they have kept at the ground level. So the only main service part actually takes place on the top of these structures. So you can see some exploratory sketches over here, like how they have actually visualized to have this wrap around structure around these trees. These are the some pictures in the night time, like how it looks like interesting to have them in this wooded area over here. And it took actually a very short time of approx only 3 months to complete actually this work over here. And since then it has become an inspirational actually piece of like a creativity of an like a architecture, of an like a adaptive like a architecture to evolve in the like these context of like sustainability, because sustainability actually demands to design in the rhythm, in the like a gel with the in the sync with the nature. And this is how actually these are the like some of these designs which have actually been executed at different places across the globe. Okay, so the minds actually, the attention given by these architects and designers actually opens up this debate, why can't we do this, why can't we actually undertake like such examples in our own places, in our own actually context. So this is an inspirational actually design pieces I have brought to give you a glimpse of like what is happening at the international level in the like a sustainability area, where they have used actually this kind of like a permeable translucent actually structures which do not create a rigid and a solid boundary between interior and exterior. Rather, they completely go gel with the nature, and that actually plays. So you can see over here in this cross section like how this structure is actually planned. So in this one, the inner surface serves as like here is the actually main seating area. You can see these 3 tables over here and 2 tables over here, and then from here actually you can go down and you can come up. So this is how it was like fabricated on the site with the scaffolding, and it uses actually acrylic sheets on the top to create to allow actually sunlight inside, and to give actually clear view of the night sky also. Since this actually project is situated in the middle of like a nowhere, middle of in the, like in a forest, so it is very fitting to enjoy actually the night sky. This uses actually this uses this philosophy actually to protect trees and develop our designs around like their own existence, so that trees also can survive. So this is like this the sustainability quotient what they have achieved is to the selection of materials, the little reliance on the outside energy sources. Okay, they have used like a natural ventilation and lighting systems. They have actually tried to leave like a minimal footprint through their like a design. Okay, and this is how actually they have designed their structures. They have done the selection of the materials which are more actually rooted to this particular place. Okay, the buildability part of it, like how easily it can be fabricated without actually external intervention or the requirement of like a heavy machinery, etc. And then accordingly they have done this programming, and the council of that place, that Auckland, they have approved, and now in the recent times it has become actually a piece of like a visit, and I think it's one of the very successful projects which have come in the recent times. Thank you everyone.